Welcome to solving logarithmic equations. We've kind of already been solving logarithmic equations in previous lessons, but we're going to do it a little bit more here too, just for some extra practice and some different kinds of logarithmic equations than what we've seen in the past. So, for the opening exercise here, we're going to convert the following logarithmic equations to exponential form. Okay, and that's going to be a general kind of skill that we're going to be using for solving these logarithmic equations. So the key thing here for solving these logarithmic equations is to isolate the logarithm. So we're going to isolate the logarithm, and we also want to rewrite as a single logarithm first if possible. So 1, rewrite as a single logarithm. 2, isolate the logarithm. Okay, so, but in this case, the logarithm is already as a single logarithm and it's isolated, it's by itself, so we'll eliminate it here. First of all, it's important to remember what is the base of a logarithm if there's no base written. It is base 10. So an exponential form here, and remember exponential form, log base b of a equals x becomes b to the x equals a. So what would this rewrite as using our exponential form here? Go ahead and do it. Okay, hopefully you took a chance to do it there. If not, pause the video and actually try it. All right, this would become 10 to the 4th equals 10,000. And check, that's true, right? 10 to the 4th is 10,000, so nothing to really solve for there. Here, again, this is log base 10, so we'll rewrite in logarithmic form. And go ahead and rewrite b and c, d and e, and even f in logarithmic form. This one you have a variable to solve for too, so try and solve for x once you rewrite it in exponential form. Sorry, exponential form is what you want to rewrite it in. Okay, is there a g here? No, okay, good. All right, so hopefully you did that. So for the first one here, we'll just have 10 to the 1/2 equals the square root of 10, which, yes, that's true, so that's true too, right? Here we'll have 2 to the 8th equals 256, and yes, if you do 2 to the 8th, out, you multiply it out, you will get 256, so that's right, Here we have 4 to the 4th equals 256. Okay, and again, that is true, so that's true. Remember that for natural log, that is log base e of 1 equals 0. It's another way to write it. And so we'll just say e to the 0 equals 1, which again is true because anything to the 0 power will give us 1, so that's true too. And then here, again, no base is given, so we assume it's 10. And so we rewrite this as 10 to the 3rd equals x plus 2, like so. So we get 1,000 equals x plus 2. Subtract 2 from both sides, you get x equals 998. Okay, kind of a crazy number there. All right, so that's kind of some basic exponential logarithmic equations we're going to solve. So let's take a look at a few more. Okay, directions here, again, help us by saying write each of the following equations as an equivalent exponential equation and solve for x. So we'll do the same thing we've been doing. All right, and if you want to, go ahead and pause the video and give it a try. Practice doing 1, 2, and 3 here, rewriting as a single logarithm first. So 1 and 2 are already single logarithms, right? But for number 3, you'll have to rewrite using your properties here with the addition as a single logarithm, and then again, rewrite as an exponential. I'll go ahead and do that right now, though. And again, if you feel like you need to see 1, then see 1, and then try the second one, okay? Pause the video and try it on your own. So here we go. Again, this is log base 10. So we'll rewrite exponential form. This will become 10 to the 0 equals 3x plus 7. What is 10 to the 0? It's 1. So we get 1 equals 3x plus 7. Subtract 7 on both sides. We get negative 6 equals 3x. Divide both sides by 3. And we get x equals negative 2. And there's our answer. Okay. Number 2, again, rewrite as exponential form. If you feel like you understood 1 okay, try 2. Okay, pause the video and try number 2 on your own. We would get 2 to the 4th equals x plus 5. And so we get 16 equals x plus 5. And subtract 5 on both sides, you get x equals 11. Okay. Last one here, number 3. This one's a little bit different because we have 2 logarithms. Remember that I said that we should rewrite as a single logarithm first and then isolate that logarithm, which we have 2 in this problem, so we want to rewrite it here, right? 2, so let's rewrite it as a single. We're going to do that because addition between 2 logarithms becomes multiplication. So it'll be x plus 2 times x plus 5, like so, equals 1. Again, this is base 10. So to eliminate, we'll rewrite in exponential form. 10 to the 1 equals x plus 2 times x plus 5. Okay, multiply this out, right, because it's going to be quadratic here, but we need it to be equal to 0. So multiply this all out here, we'll get x squared plus 7x plus 10 equals 10. Subtract 10 on both sides so we can use that zero product property. We're going to get 0 equals x squared plus 7x. Okay, now remember, when it comes to solving a quadratic equation that's equal to 0, okay, we're going to try and factor, right? And we always should check a greatest common factor first before we try and factor, the normal quadratic way. And there is a GCF here. What is it? We can take out an x, and that'll leave behind what? What will be left in the parentheses here? X plus 7. Set each then factor equal to 0, and we get our solution there, and x is -7 is our other solution. Okay? All right, we'll stop there, and in the next video we'll get into some of these exercises too.